Okay, grade 12s, let's have a look at some more examples on the counting principle. It says, in a company there are 3 vacancies. The company identified possible candidates to fill each post. For the post of admin clerk, we have potentially Chris, Lenny, and Tim. Okay, for sales representative, we have 4 people. So there are 3 here. There are 4 sales reps, that Alessandra, St. P. and Dion. That could be sales reps. And sales manager, there are 2 people, James and Diane, that could occupy those posts. In how many different ways can these 3 posts be filled? Well, you could have Chris, Alice, and James, or you could have Chris, Sandra, and James, or Chris, Dion, and Diane. There are many different ways that we could appoint. We don't know who's going to make the position. Okay, but so what possible ways could exist? Well, in number A, very simply put, would be 3 multiplied by 4 times 2, which gives you 24 possible ways that these posts could be occupied. Okay, and now be careful with this. This next one is very, very important. It says there, if it is certain that Lenny will get the job as clerk. So we're definitely going to have Lenny getting the job as an admin clerk. So how many people occupy the admin post? It goes down to only 1 person. No one else. Lenny occupies. He's been given. We know for sure that he's the admin clerk. So there's only 1 person who can occupy that post. But for the other 2 posts, the sales reps and the sales managers, there could be 4 people or 2 people for sales manager. So in how many different ways can the 3 posts now be filled if it's certain that Lenny will get the job? 1 for Lenny, 4 for the sales reps, and 2 possible positions therefore, or 2 people could have taken the sales manager place, James and Diane. So that gives you 8 ways. So you can see we've restricted this to Lenny in the first position as the admin clerk. Okay. Very important, the counting principle. Have a look at a second example quickly. In how many different ways are there of predicting the results of 4 soccer matches where each match can end in a win, a lose, or a draw? So there's 3 possible results in each soccer match. So let's look at the first soccer match. There's going to be 4 soccer matches played. You could have a win, a lose, or draw. So there's 3 possible results there. In the next match, you could have a win, lose, or draw. In the third match, a win, lose, or draw. In the fourth match, a win, lose, or draw. So if you multiply those, that's going to give you 3 times 3 times 3 times 3, which is 3 to the 4, which is 81 possible results or ways that the matches could have turned out. You could have had in the first match a win, the second match a lose, the third match a draw, and then back to a win. Or you could have had 4 losers, a lose, a lose, a lose, a lose, or 2 wins and 2 losers. But there's 81 ways or results that could have happened with these 4 soccer matches. Okay, this is the counting principle. Now this one I want you to watch very carefully. This is a really nice example. You have got the first 4 letters of the alphabet given to you. Okay, we're going to work with the first 4 letters, A, B, C, D, and we want to form different 4-letter arrangements. Okay, 4-letter arrangements. Okay, and using the letters of the alphabet, these first 4. An example would be, for example, you could have B, C, D, C. Notice we've repeated the letters there. Or you might like to have, say, D, B, A, C. That's another arrangement of the letters, a 4-letter arrangement using A, B, C, D. Notice here we're not repeating, whereas here in B, C, D, C we can repeat. You could have also had A, or you could have had C, C, D, D as well if you're repeating, or you could have had B, A, D, C if you weren't repeating. These are called 4-letter arrangements. Okay, now let's have a look. How many possible arrangements can be made if the letters may be repeated? Well, pretty straightforward. You've got the letters A, B, C, and D, and you want to create a 4-letter arrangement using any of these, and you can repeat. So how many letters could you have used for the first letter? There's 4. You could have used A, B, C, or D. Okay, now when you come to the second letter, you could have used A, B, C, D again. And likewise for the third letter, you could have used any 4. And likewise for the last position there, you could have used any of the letters because you may repeat. So what are the possible arrangements that can be made if the letters can be repeated? Would be 4 to the exponent 4. And if you work that out there, that would be 704 possible arrangements or 4-letter arrangements that can be made. But now, if you may not repeat the letters, now we open a different can of worms. Now watch this. There's 4 letters. Now, there are 4 positions that these letters could take. Now let's suppose I'm going to have a 4-letter arrangement where I may not repeat the letters. So let's suppose that I decide to choose A. So A goes into this first position. I could have had B, C, or D. So there's 4 possible letters that could have gone into that position there. Okay, now I'm going to write the 4 at the bottom here. If you think about it carefully, there's 4 possible letters. Now let's suppose that I chose the B. Okay, and B is going to go into that position there. Okay, now we may not use B again. Okay, we may not use B again. Okay, so now for the second position, we only have 3 choices, A, C, and D. Okay, now we're going to pick a letter. Let's suppose we choose the A. Okay, and A goes into the position there. Okay, great. So now we've used a letter, the one of the 3. Now when we go to the third position, we only have 2 to choose from because we may not repeat B or A. Okay, so what do we have now? Well, we've got C and D. Let's suppose we choose D, for example. Let's take D and we move D into position there. Great, now we've used one of those 2. Now in the last position, there's only 1 left, and that one is going to be C. So C fits into there. Whoopsie, let's just make it neat there. Let me bring that down. There comes C, and in we go. So you can see, so how many possible arrangements are there? Very simply, 4 letters can be used for the first position. Then we can't use the letter we've used like we did B. So now we're down to 3. Then in the third position, we can only use 2. And in the fourth position, only 1. So that is going to be 4 times 3 is 12. 12 twos are 24 possible word arrangements in this situation there. So that is so important. And by the way, I've got a little definition for you when you talk about 4 times 3 times 2 times 1. We refer to it as what we call a factorial. Okay, and what we do is if you've got 4 times 3 times 2 times 1 going from 4, 3, 2, 1 down, we refer to this as 4 factorial. It's like an exclamation mark. Your calculator actually has that on. If you look at this, if you go, if we can find it there it is there. So if we go 4, shift, and then see that little exclamation mark there, factorial equals 24. It's going 4 times 3 times 2 times 1. So what would be 6 factorial? That would be 6 times 5 times 4 times 3 times 2 times 1. And if you work out that, that's very simply put. If you're going to have a look at that, let's go there. We go, let's cancel 6. Shift factorial there, which is the exclamation mark, comes to 720. Okay, so 5 factorial would be 5 times 4 times 3 times 2 times 1. Okay, and by the way, don't worry about that, but naught factorial is going to be 1. And as we go through these lessons, I'm going to explain to you why that is so, why naught factorial is in fact 1. Okay, very interesting, these word arrangements where you get a 4-letter word arrangement or just a letter arrangement where you arrange letters where they can be repeated or not repeated.